In this video, I'm going to show you how to make a door that always opens away from the player in Unreal Engine 5. This tutorial will be super straightforward, so without further ado, let's get straight into it. We are going to start by making the door blueprint. Open the Contents browser and right-click. Go to Blueprint class and select Actor. Call this BP_door. Open it, then go to Add. Select Static Mesh and name it Door. Go to the Static Mesh drop-down and find your door asset. Add it, then make sure that the pivot point is in line with the edge of the door. Next, select the default scene route and add a box collision. This will be used to allow the player to interact with the door. Move and resize the collision box so that it stretches out in front of the door. Compile and save. Then open the event graph. Next, we need to set up a way for the player blueprint to communicate with the door. To do this, we are going to use a blueprint interface. Go to the Contents browser and right-click. Go to Blueprint and select Blueprint Interface. Call this BPI_interacting. Open it. Name the function Interact. Compile and save, then go back to the door blueprint. Click Class Settings, then go to Implement Interface and select the one you just made. Right-click on the Interact interface and select Implement Event. This event will be triggered in the player blueprint when they interact with the door. Drag off and add a flip-flop node. Then drag off A and add a timeline. Call it TL_door. Double-click on the timeline node to open it. Click Add Track, then Add Float Track. Call this Alpha. Set the track length to 0.2, then hold Shift and left-click on the graph to add a point. Ensure that the time and value are both set to 0. Shift-click on the graph again to add another point. Set the time to 0.2 and the value to 1. Compile and save, then go back to the event graph. Connect B to the reverse so that the door can be closed, then right-click and add a lerp node. Connect the alpha to the alpha and set the B value to 90. The lerp node allows the door to rotate between two positions. Next, drag the door mesh onto the graph. Drag off it and search for a Get World Rotation node. Add it, then connect it to Update. Right-click on the new rotation pin and split the pin structure. Connect the lerp to the Z value. Compile and save. Next, we are going to add inputs so that the player can interact with the door. Go to the Contents browser and locate your Inputs folder. Right-click, go to Inputs and add an input action. Call this IA_interact. Open it and make sure that the value type is set to Digital Bool. Save and close, then go back to the Inputs folder and open your input mapping context. Click Add to get a new input and select Interact from the drop-down. Click the keyboard icon and press E to assign it to the input. Save and close. Go to your Blueprints folder and open your character blueprint. Right-click and add the Interact input action. Drag off Started and add a multi-sphere trace for object. This creates a sphere around the player which will detect whether the player is next to the door. Drag off Start and search for Get Actor location. Add it, then connect it to the end pin as well. Drag off Object Type and add a Make Array node. Go to the drop-down and select World Dynamic. Set the radius to 64 and the Draw Debug Type 2 for duration. Drag off Out Hits and Adder for each loop. Connect it up, then drag off the Array Element pin to add a break hit result. Expand the node, then drag off Hit Actor. Search for a Does Implement Interface node and add it to the graph. Go to the drop-down and select the blueprint interface you made. Drag off the return value and add a branch to the graph. Connect this to the for each loop. Drag off the hit actor pin, search for Interact and add it. This node will trigger the event in our door blueprint. Connect it to True, then add a reroute node to keep things tidy. Compile and save, then go to the viewport. Go to the Contents browser and drag in your door asset. Click Play and use the E key to test your Interact mechanic. When standing away from the door, the sphere will appear red, indicating that nothing has been hit. When the player is near the door, it will appear green and the door will open and close. Currently, the door only opens in one direction. If we want the door to always open away from the player, we need to get the player's location in relation to the door. Go back to your blueprint interface and add an input. Call this location. Set the type to vector. This will communicate the player's location to the door blueprint when it is interacted with. Next, go to the character blueprint and drag off the location pin. Search for Get Actor Location and add it. Then go over to the Multi-Sphere Trace node and set the Draw Debug type to None. Compile and save, then go to the door blueprint. Make some space, then right-click and add a Get Actor Location node. Drag off that and add a Get Unit Direction node. Connect it to the location pin. Drag off and add a Dot Product node. Drag off this pin and add a Get Actor forward vector. Drag off the dot product and add a greater than or equal to. Drag off one more time to get a Select Float node. Set the A value to -90 and the B value to 90. Right-click on the return value pin and promote it to a variable. Call it rotation. Connect it between the flip-flop A value and the timeline. Drag in the rotation variable and plug it into the lerp's B value. The dot product produces a positive or negative value depending on which side of the door the player is standing. This is used to decide which direction the door should rotate. Finally, add the timeline to the graph. Drag off it and add an IsPlaying node. Next, add a branch just before the flip-flop and connect the IsPlaying return value into it. This will ensure that the door is fully open before it can be closed again. Compile and save, then go back to the viewport. When you press play, you should have a door which always opens away from the player. I hope you found this video helpful. If you did, please feel free to like the video and subscribe to my channel as it helps me out a lot. If you would like to support me in making these tutorials, please take a look at my Patreon linked in the description. If you have any questions about this tutorial or suggestions on ones I should make in the future, leave them in the comments below. Thanks for watching.